Welcome everyone. Good morning, good afternoon, and good evening from wherever you are. This talk is going to be about Kubernetes security, attacking and defending Kubernetes clusters. As Anne said, my name is Magno Logan, and I work for Trend Micro doing security research. So just a little bit about myself. As I said, I work at Trend Micro. I'm part of the cloud and container security team. I'm also a member of the CNCF tag security team, which is the group inside the Cloud Native Computing Foundation that focuses on security matters for the cloud native applications. I've been involved with OWASP since 2011. I led this OWASP Paraíba chapter back in Brazil for 5 years, and then be involved in different chapters and different projects as well. I also have a personal blog where I post articles regularly. There's also all my contact information there, and all my previous talks as slides or videos since 2011 as well, when I started doing some public speaking in conferences. Okay, so this is our agenda for today. I'll try to cover as much as I can in 25-30 minutes. But yeah, basically we're going to talk about Kubernetes attacks and how to understand what attackers are doing in those environments and how can you protect yourself from those famous attacks. Before I start, I just want to say that if you're beginning your Kubernetes journey, or if you're starting your research in Kubernetes security, I created this GitHub repository that's open and available to everyone. That's called the Awesome Kubernetes Security List. It has a lot of materials, books, presentations, slides, and a lot of interesting things, not just for Kubernetes security, but also for someone starting their Kubernetes journey, because you need to understand the technology first so that you can focus on security later, right? So I think that's a really awesome project that I started since October last year, and it's been growing really fast. So feel free to start and fork it and submit any other links that you might have. So yeah, this presentation, as we're going to talk about attacks, right? We have to mention the MITRE ATT&CK framework, which is globally accessible knowledge base, right, of opposing tactics and techniques based on real world scenarios. And it's used as a basis for development of specific threat models and methodologies in many different sectors. And what was interesting to us when we started doing cloud and container research was, yeah, there was a MITRE ATT&CK framework for the cloud, but there was none for containers until this year, right? So MITRE started this kind of call to the community, asking for help and for data related to in the wild attacks or real world scenarios that could be used to create this kind of MITRE ATT&CK matrix for containers, right? But before that, there was one matrix that was released by Microsoft, but the guys at Azure are based on what they've seen in their own environment, so mostly K8s and their Kubernetes managed services. And then they released a new updated version this year as well. This is not an official MITRE matrix, but it can give you a great overview if you're looking to deploying Kubernetes on Azure and understanding, okay, what are the main techniques that attackers are using to compromise my environment in Azure, right? So from December last year to April this year, we started working with MITRE, and not just us as in Trend Micro, but other organizations as well, providing data and research information based on what we've seen in the wild, what we've seen in our Docker honeypots and our Kubernetes honeypots, and analyzing what attackers are doing, right? And so this was the kind of the first version of the MITRE ATT&CK for containers. And I'd like to add that it's also about Kubernetes, because there are some techniques there that are very specific to orchestrator or Kubernetes environments, right? So out of those 28 techniques, we came up with, I think it was 7 or 8 techniques that we contributed to. And two of those techniques were brand new ones, techniques about attacks that haven't been seen in the wild or weren't categorized in the MITRE framework. Okay, that's interesting. But before we had that cool matrix, we were already doing some threat modeling in Kubernetes environments. And here is the threat modeling that I did, also based on the MITRE attack framework. As you can see, there are the tactics on the left. I don't know if you can see if it's a bit small there, but basically looking into a scenario where there is a web application, right? And this web application is running inside a container or inside a pod in a Kubernetes scenario. And that application is exposed to the internet and has a vulnerability of remote command execution, right? And from there, from that vulnerable application, the attacker can compromise the Docker container and then get inside your cluster and try to move laterally and compromise also your worker nodes or your cloud environment if you're running on that. So we're going to analyze this using this threat model as a baseline. We're going to analyze this scenario and see some common attacks that are possible in this in kind of this scenario here, and see later what we can do to avoid this from happening. Okay, yeah, this was kind of the website that I created, which I use for my threat modeling. Basically, a vulnerable Drupal web application from 3 years ago, from version 8.5, and I just kind of made it a little bit interesting to hack. So the initial access, right, with the application, since this is outdated systems, it has a remote command execution vulnerability from the CVE there that you can, the exploit is available on the internet. You can easily download and exploit that as well, right? This is one of the initial accesses possible in a Kubernetes environment. Other two scenarios was the exposed dashboard for Kubernetes, which is not enabled by default anymore. So that's not the case, depending on the version of Kubernetes that you have. But there is also the Kube API server, and which is basically the main entry point of all requests to the Kubernetes and to the control plane, right? So especially on managed service providers such as AWS and Azure and Google, you have to be aware of if your Kubernetes API server endpoint is public by default, right? Some services like K8s, they are. So like, do you really need that? Do you really want, if someone finds that API, the endpoint, do you really want them reaching that and finding information about your cluster, the version of your Kubernetes, version of the Golang that's being used by your Kubernetes as well? So there's a lot of sensitive information there. So here is the API endpoint, just two examples there. One is unmanaged Kubernetes cluster. So by default, the API server runs on port 6443. And the second example is a managed cluster running on K8s, as you can see from the URL there, and it runs on the port 443 by default. So from there, depending on the permissions that you have, you can either just get version information or health information, which are the common public API endpoints. But if that cluster is misconfigured, right, and it's not properly protected, there are other things that you are able to do. So one of interesting tools that are available if you don't know much about Kubernetes and you need to either exploit a Kubernetes cluster or evaluate the security of your own cluster, there is this tool called KubeHunter, which is an open source tool provided by Aqua Security, and it helps you hunt for security weaknesses in Kubernetes clusters. It has kind of 37 rules or vulnerability detections. There are misconfigurations that help you get a better overview of the security of your cluster. Okay, let's say, yeah, I was able to exploit that vulnerability, that CVE, remote command execution, and I have access inside a container of the web application inside the pod, right? So here are some sensitive information that I can find out or grab from that pod that would probably leverage me into move laterally and find other entry points or escalate privileges, something like that, right? So first thing is the environment variables, right? If you check the Kubernetes environment variables, they're usually there for every pod and by default has information about the API server, IP, the port, and other stuff that's running. Also, on every pod, there's a location where they store the service account and the service account token, and that service account you can use to talk to the API server, right? So if you can grab that information, which is easily available once you have access to the pod, then you can impersonate the kubelet and talk to the API server. And there's also another tool that's available on GitHub that's called MI Contained, which is basically a tool that runs a bunch of checks and tells you if you are in a container or Kubernetes environment. It checks for if the SecComp and AppArmor are enabled, and also which capabilities you have on that container. So that's pretty interesting. So yeah, another possibility of attack, and we've seen that in the wild in our honeypots, is the kind of privilege escalation and kind of breaking out of that container and that cluster, right? Here is an example provided by Duffy Cooley from Isovalent, which deploys basically a privileged container in the cluster, allowing you to break out of that environment and accessing the worker nodes, processes, and files and everything, right? So one of the honeypots that we deployed in the wild, it took less than 24 hours for the attackers to compromise that web application, right? Get access to the worker nodes, right? Escape the container and get access to the worker nodes. And even after that, they were able to grab the API keys of the cloud environment through the instance metadata, and they were able to deploy big instances and to mine cryptocurrencies, right? So this is kind of 95 to 99% of the attacks out there for Docker and Kubernetes. They usually either compromise your running containers to mine cryptocurrencies, or they deploy other new containers or other instances to do that. So that's something that you need to be aware of. Okay, so how can I defend Kubernetes, right? How can I protect my cluster from attackers? Isn't Kubernetes secure by default? Where do I start, right? So basic thing, the first thing that I mentioned in the beginning was the Kube API server, right? If you can see here, even though I search the root endpoint here of the API server, it already returns some information for me telling the API version, the status, and I can clearly see that this is a Kubernetes server running there, right, in the IP. And there are attackers monitoring the internet, and you can find information on Shodan and Census and all those tools to find public available servers that there is a lot of clusters exposed out there that shouldn't be, right? So you if there isn't a specific business need, you shouldn't expose your Kube API server to the internet. Another great guidance here is the CIS Kubernetes benchmark, which is a document created by Rory McCune and Liz Rice and other many contributors, and they are security professionals in the cloud native world. And it has like 100 plus security checks for your Kubernetes clusters. And the interesting thing is that it shows you how to check if that proper setting is enabled for your cluster. And if that's not the expected result, it shows you also how to fix that and enable that checking, right? So that's really interesting. And it has also specific documentations for EKS and GKE, and I think AKS for Azure, it should be out there soon. Of course, you're probably not gonna do that manually and this is a OWASP event. We're talking about DevOps and DevSecOps and automation. So someone already solved that problem for you, which was also open source tool from Aqua called Kubebench, which you target your Kubernetes cluster and it runs all the checks that are recommended by the CIS Kubernetes benchmark, and it sees if your cluster is following those recommendations or not. So there's like a pass or fail check, and also like a warning and tells you what you need to fix. So it's developed in Go and it's also open source. Anyone can contribute to it. Here's a basic example of the output of the Kubernetes benchmark. As you can see here, my cluster wasn't very compliant to those rules. Okay. Another thing that we need to be aware of is and we've been talking about supply chain attacks and SBOMs, right, and software composition analysis. So even before you deploy a Docker image or any kind of a container image to your cluster, you need to be aware of any kind of vulnerabilities that may be there, right? So scanning that image for vulnerabilities or for any kind of misconfiguration or malicious software, it should be also a step that you take before even deploying those in your cluster, right? So there are many tools out there that can do that for you, even depending on the container registry that you're using. They already ran some scans, and these are some of the famous ones out there. Okay, now, yeah, you scan the images that they are properly scanned. They don't have any kind of critical vulnerabilities, and you deploy them, right? Okay, but what happens after they're deployed, right? What happens if there are any changes, or, for example, in our attack scenario here, the web application, the container is compromised. How do I know that something is going on? So that's a bit tricky, because on container environments, sometimes you don't have enough visibility with an agent installed on the node, or unless you're using the new technology such as eBPF. And also on managed services for Kubernetes, you usually don't have access to the control plane of that cluster, right? The cloud provider manages that for you, which is a good thing, but it also is a bad thing because you don't have SSH access and you can't install agents to monitor that node for any kind of security issues, right? So that's why here comes like Falco, which is an open source security tool from the Cloud Native Computing Foundation. Was developed by Sysdig, and it uses kind of the eBPF technology to parse Linux kernel syscalls at runtime, right? So it's basically the IDS of Cloud Native applications. It detects any kind of unexpected behavior in the cluster. It's a rule-based engine, right? And you can create your own rules, and it generates alerts based on those threats detected. So once you have those containers running, you should have something monitor, something such as Falco, to monitor any kind of drift detection, any kind of changes, any kind of updates or tools being installed, or programs being executed, right? Processes being executed, such as the ones like mining Bitcoins or cryptocurrencies. Other recommendations here, more in general, is for your pods itself, right? There are 3 things that you need to be aware. The pods in Kubernetes is basically your containers, but in the pods, you can have 1 or more containers running on the same pod. So the first thing is limit resources, right? You don't want your containers demanding more resources than your nodes can provide, and then causing a denial of service on your node because of lack of resources. So limiting that on your cluster is very important, and it's a basic kind of verification, as well as availability is part of security, right? Other things that you can do is apply a security context, right? There are some settings there that you can configure on your pods that, for example, here I just bring 3 of them, but there are much more allow privilege escalation equals false, right? I don't allow this process to escalate privileges. Read-only root file system, right? Set to true, and run as non-root, right? So as much as it's, I think it's complicated to do, we don't want our containers running as root, right? Especially if they are doing kind of sensitive tasks or have access to sensitive information. Another thing with the pods that you can do is setting the Linux kernel security modules, right? The LSM, such as seccomp, AppArmor, and SC Linux, right? So there are specific ones that you can enable there, and at least setting one of those would greatly help your security overall of your containers and avoid any kind of container breakout there. So yeah, the security context is interesting, but how do you scale that? So there was something that was used for that. It was called the pod security policy, but that's now being deprecated. You could apply that policy with all your security context to your whole cluster. There is a new policy, I think it's coming up in the new Kubernetes version already, but there is also some alternatives, and you can use that to protect your cluster. So how the pod security policy works, it works as an admission controller, right? So what does that mean? Basically, it controls the admission to the cluster, right? It's kind of the security guard of a nightclub. It checks if your container has been scanned, checks if there are any critical vulnerabilities. You can establish your own policies and see if it's coming from authorized registry and not being downloaded from Docker Hub or something like that, right? So you can do that with admission controllers on Kubernetes. Other tools that are alternatives to a pod security policy that you can use, they're also very famous there. It's OPA Gatekeeper and also Kyverno. One other thing that's really important on Kubernetes and really hard to get it right and really easy to make mistakes is the role-based access control, right? Just like many web applications that we use nowadays, they use role-based access control, right? Kubernetes also does that. Now that's enabled by default with Kubernetes. Before a couple versions, it wasn't. And all it does, it creates 4 different objects in Kubernetes, allowing you to define a set of permissions and providing that to specific users. So on the RBAC or role-based access control, you have a role, which is an object that contains rules and represents like a set of permissions within a namespace. And you have a role binding, which is basically this object grants the set of permissions from a role to one or more users, right? And the other 2 objects that you have is the cluster role and cluster role binding, and which work kind of the same way as the role and role binding, but those permissions apply to a cluster level, right? So in Kubernetes, we have something called namespaces, which are basically kind of folders that allows you to separate your projects. And it's a logical separation. There's no like kind of security boundaries related to it. But you can maybe have like a dev namespace, a QA, a production namespace, or you can have namespaces separated by different teams, right? And so that's why this role is very specific one, and the cluster role is more general, more permissive, because it applies to the whole cluster of your Kubernetes environment, right? So you need to be aware of that as well when you're giving permissions to your users on Kubernetes. One more thing, and I think on Kubernetes, there is like the database or the main data storage location for a cluster. It's by default, it's etcd, right? It's a key value store has all your cluster objects, all your configurations are saved there. But we found out earlier this year that over 2,600 instances of etcd are exposed on Shodan, right? And not necessarily connected to a Kubernetes cluster, because you can have etcd as a standalone key value store, but they usually have sensitive information, right? It's just like exposing your database to the internet. So that's something that you need to be aware of. And one thing on etcd that's done by default is the encryption in transit, right? Which is great, but the encryption at rest is not done by default, right? By default, everything that you have on your cluster, all the configurations, all the sensitive information, even the secrets are stored in plain text on etcd. To encrypt that, you need a specific object called the encryption configuration object to be able to protect your sensitive information. Another thing that from security perspective can be very kind of surprising and scary at the same time is that by default on Kubernetes, all the pods, all the containers can talk to any other pod in the cluster. So it's just like a flat network, right? From a security perspective, when I found that out, like, oh my God, right? So yeah, make sure you create a proper network policy for your cluster. So network policies are objects that you can kind of segregate who can talk to who inside your cluster, right? So does the front end pod really need to talk to the database pod or not, right? So something like that, it's very important to have on your Kubernetes cluster. And last but not least, the audit logs. This is also something that are not enabled by default on Kubernetes, and it's highly recommended that you do that. Enable them for security and troubleshooting, right? Basically, you need two things to enable these audit logs: a log path where you're going to store this file, and a policy file, right? What are you going to log, right? And you can set those up on the Kubernetes API server configuration, right? Basically, there are four logging levels: non-metadata, request, and response. And you can set those up and configure what are the logs that you want. And you can also send them to a specific location, like a SIEM server, or on the Kubernetes managed services, for example, for in EKS for AWS. They are sent to CloudWatch, where you can later grab them and send to like an S3 bucket or to your SIEM of preferences. Okay, just to conclude my presentation here, but just remember the basics, right? I know there's a lot of information here, a lot of stuff that you need to do before and after you deploy a Kubernetes cluster, but remember the basics, right? Kubernetes changes version very early and often. I think now it's 3 times a year. And the latest version was 121. When I wrote this presentation, I think I already changed to 122, right? So it updates very often. So be aware of that. Don't use the cluster admin for your daily work. Treat it like root, right? You don't want to use root for everything as well. And if you're just beginning your journey in Kubernetes and you're just learning, and it can be daunting and it can be a lot of complex stuff to learn, try using a Kubernetes managed service such as EKS, AKS, or GKE, because a lot of the security stuff and a lot of the kind of the grunt work they handle for you. So it's probably better to try that first. And don't forget to check out the Kubernetes, the CIS Kubernetes benchmark for more security best practices. So thank you for everyone for having me here, and for OWASP for this great event. And I'll be available on Slack for questions. Thank you.